We don't come back again. H Radio School don't come back.
Hello everyone, I am Mr. D, your favorite radio school teacher. On February 1st, H Radio School will be coming back to teach you literacy, numeracy, and STEM subjects.
This is for out-of-school children.
We will teach primary topics on Mondays at 11 a.m., secondary topics on Tuesdays at 11 a.m., and we will have a repeat episode on Wednesdays.
Hope all of una don hear o. Make una tune in on Mondays, Tuesdays, and Wednesdays around 11 a.m. Parents, if your pikin no dey go school, make una try make dem go school for radio so your pikin fit learn. This is an ACE charity initiative powered by Grand Force Foundation.
This is a secondary school session for out-of-school children. Hello listeners, my name is Adesami Temitayo and I welcome you to today's English class on ACE Radio School. In our last lesson, we learned that a tense is a form of verb that shows the time an action happened or is going to happen. And we studied 3 types of tenses with examples. The tenses studied were the simple present tense, present continuous tense, and can someone remind us the last one? Did I hear you say present perfect tense? That is correct. In today's lesson, we shall learn 3 other types of tenses, which are present perfect continuous tense, simple past tense, and past perfect tense. We'll start with the present perfect continuous tense. The present perfect continuous tense represents an action which started in the past and is still running or continuing. It uses have been, has been, and ing together with the main verb. I take that again. The present perfect continuous tense uses have been, has been, and ing together with the main verb. Let's take a look at some examples. They have been playing football for 2 hours. He has been building his house since last year. Abdul has been studying in the library since morning. My mom has been cooking for 3 hours. Did you notice 3 things in all the sentences? 1. Each sentence either has the word has or have. 2. This is followed by the word been. 3. The word that follows after is a verb ending with ing. Example, has been sleeping. We go to the simple past tense. The simple past tense shows that an action started and was completed at a particular time in the past. It also indicates a past habit which the person being referred to and is no more involved in. Something you used to do before and you're no longer doing it. Let's take a look at some examples of the simple past tense. David passed his English exam last year. He built his house last year. Abdul studied in the library this morning. My mom cooked for 3 hours. Let's go to the past perfect tense. Past perfect tense. The past perfect tense indicates that 2 or more actions took place in the past, but one happened or was completed before the other. The action that happened first is expressed in the past perfect tense, while the other action is expressed in the simple past tense. Past perfect tenses uses had and the past participle form of the verb. Examples: the thief had escaped before the police got there. By the time I got to the class, the teacher had left for a meeting. They had played football in that field before it started to rain. I came here after you had left. Did you notice that before each past tense verb there is the word had, like had gone, had slept, etc. Alright, let's do a recap of what has been learned today. We learned about 3 other types of tenses, which are, can we name them? Present perfect tense, no. Present perfect continuous tense, very good. Simple past tense, and the last one is, can someone say it? I can't hear you. Past perfect tense, very good. Now it's question time. As usual, I'd like you to listen attentively to the following questions and choose the option with the correct answer. Question 1. What tense is contained in the sentence, I helped him to do the task after lunch? A. Simple past tense. B. Past perfect tense. C. Present perfect continuous tense. Question 1 again. What tense is contained in the sentence, I helped him to do the task after lunch? A. Simple past tense. B. Past perfect tense. C. Present perfect continuous tense. Question number 2. Which tense shows an action that has been completed in the past? A. Past perfect tense. B. Simple past tense. C. Present perfect continuous tense. Question 2 again. Which tense shows an action that has been completed in the past? A. Past perfect tense. B. Simple past tense. C. Present perfect continuous tense. Question 3. What tense indicates an action that is being continued from the past? A. Past perfect verb. B. Past perfect continuous tense. C. Past continuous tense. Question 3 again. What tense indicates an action that is being continued from the past? A. Past perfect verb. B. Past perfect continuous tense. C. Past continuous tense. Send your responses as a text message indicating your name, gender, state, and subject, that is English, to 070-363-03182. The number again is 070-363-03182. Alright, well done students for participating with your friends in today's English lesson. You can catch up on past episodes on our YouTube channel called Ace Radio School. Don't forget to subscribe. Until I come your way again, it's Adesami saying bye for now.
This is an ACE charity initiative powered by Grand Force Foundation.
This secondary school session is for out-of-school children. Hello listeners, my name is Mrs. Oluwashina Teniola and I welcome you to today's mathematics class on ACE Radio School. Today, I'll be teaching integers. I will explain how to add negative numbers. Get your pen and notebook and let's get ready to learn. Previously, I explained that integers are collections of all positive numbers and negative numbers, including 0. I'll take that again. Integers are collections of all positive numbers and negative numbers, including 0. We are quite familiar with numbers from our early years. 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. These are known as positive numbers, while the numbers with the negative sign are negative numbers. Examples are -1, -2, -3, -4, and so on. Negative numbers always have a minus sign before the number. Negative numbers always have a minus sign before the number. It is very easy to add positive numbers together. For example, 4 plus 5 equals 9. That's quite simple. However, we can also add negative numbers together. Let's consider this example. -3 plus 5. -3 plus 5. Firstly, you should see the negative number as a debt owed. Then see the positive number as excess money. Now, you are owing a friend 3 naira. That is -3. Then you got 5 naira to pay back your friend. That is +5. Will you still be owing him? No. Rather, he'll give you a balance of 2 naira. This means that you have extra 2 naira left, which is +2. Therefore, -3 plus 5 equals +2. Great job! Let's consider another example. -10 plus 15. -10 plus 15. Firstly, you should see the negative number as a debt owed. Then see the positive number as excess money. Now, you are owing your sister 10 naira. That is -10. Then you got 15 naira to pay back your sister. That is +15. Will you still be owing her? No. Rather, she will give you a balance of 5 naira. This means that you have an extra 5 naira left after paying what you owe, which is +5. Therefore, -10 plus 15 equals +5. Great job! Shall we consider this exciting example? -150 plus 100. -150 plus 100. Let's use a story to solve this question. Musa collected 100 naira from his mom to buy bread at Malam Hassan's shop. When he got there, Malam Hassan told him that the price of bread is now 150 naira. Musa pleaded with Malam Hassan that he only had 100 naira with him and that he will bring his balance later. How much do you think Musa will be owing Malam Hassan? Musa will be owing Malam Hassan 50 naira. Correct! Because Musa is still owing Malam Hassan, the answer is -50. Therefore, -150 plus 100 equals -50. Great! Try this example. -80 plus 50. -80 plus 50. You can also form a story out of this. Listen to mine. Ade borrowed 80 naira from Uche. Ade promised to pay back the following day. The following day, Ade could only give Uche 50 naira out of the 80 naira borrowed. Is Ade still owing Uche? Yes, Ade is still owing Uche 30 naira. Because Ade is still owing Uche, the answer is -30. Therefore, -80 plus 50 equals -30. Great job. Quite easily done. Well done, listeners. We have come to the end of today's session. Today, we learned about integers, that is negative numbers. We learned how to add negative numbers. I'd like you to try this as an assignment and send in your answers to this phone number 070-3630-3182. Type your name, age, gender, if you're a boy type male, if you're a girl type female, your class, and the state you currently live in. I hope you have done that. Now the questions. 1. Work out -60 plus 20. Work out minus 60 plus 20. 2. Work out minus 100 plus 120. Work out minus 100 plus 120. Okay, I'll be expecting your answers. You can catch up on past episodes on our YouTube channel called Ace Radio School. Don't forget to subscribe. Remember that we air primary episodes on Monday, secondary episodes on Tuesdays, and repeat episodes on Wednesdays. Until next time, it's bye for now.
We don't come back again. Ace Radio School don't come back.
Hello everyone, I am Mr. D, your favorite radio school teacher. On February 1st, Ace Radio School will be coming back to teach you literacy, numeracy, and STEM subjects.
This is for out-of-school children.
We will teach primary topics on Mondays at 11 a.m., secondary topics on Tuesdays at 11 a.m., and we will have a repeat episode on Wednesdays.
Hope all of una don hear o. Make una tune in on Mondays, Tuesdays, and Wednesdays around 11 a.m. Parents, if your pikin no dey go school, make una try make dem go school for radio so your pikin fit learn. This is an ACE charity initiative powered by Grand Force Foundation.
This secondary session is for out-of-school children. Hello listeners, my name is Mrs. Mosi and I am your ACE Radio School Science teacher. This month, we are going to be learning chemistry. Welcome. In this lesson, we are going to be learning about the laws of chemical composition, and we will begin with the law of conservation of matter. Let us begin. Make sure you listen attentively. Have you heard of Dalton's atomic theory? Dalton, D-A-L-T-O-N. Dalton's atomic theory states that matter cannot be created nor destroyed. This theory dates back to 1789 to when Antoine Lavoisier discovered that matter can neither be created nor destroyed in a chemical reaction. I'm going to explain using an example. When we burn coal, it will seem as if all the matter in the coal has been destroyed. But that is not true, because the coal is converted to ash. When you measure the coal and the ash will weigh far less than the coal. In this case, it will seem like some matter got destroyed since they are not the exact same weight. However, we have to know that when the coal was burning, invisible products such as carbon dioxide, steam, soot, etc. were also given up. Therefore, if we add the weight of all those substances that were given up during the combustion of the coal, the total mass will be almost equal to the coal before it started burning. This is because heat and light are also part of the product that is given out when coal is burnt. If it were possible to calculate the weight of the ash, the steam, the soot, and other substances that were given off while burning, the weight will be equal to that of the coal being burnt. Then we'll realize that matter has not been destroyed. Einstein derived an expression for the conversion of matter and energy, which is E is equal to mc square, where E is energy, m is the mass, and c is the velocity of light. This theory is what is called the law of conservation of mass, which states that matter can neither be created nor destroyed in a chemical reaction. Next is the law of definite proportion or constant composition. This law states that a chemical compound is always made up of exact same proportion of elements by mass. For example, if a compound is made by combining 1/4 from one chemical and the remaining 3/4 from another chemical, these proportions will always hold true irrespective of the amount of chemicals added. For example, a sample of pure water contains 88.81 hydrogen and 11.19% oxygen by mass. We all know water can be obtained from different sources: rainwater, river water, borehole water, seawater, etc. If water from these sources are analyzed, we will find out that water from each source contains hydrogen and oxygen in the same composition by mass. Therefore, it does not matter where the sample of water came from or how it was prepared. Its composition, like that of every compound, is fixed. This fact can therefore be stated in the form of a law called the law of definite proportion or constant composition. Another example is salt. Salt is written as the chemical compound sodium chloride, that is NaCl, and is made up of atoms of sodium and chlorine. It does not matter where the salt is obtained from. The exact same proportions of sodium and chlorine must always be combined in order for salt to be created. I hope you are all following me. In essence, what I have been saying is that if a compound is formed, the composition of that compound is going to always be the same, even if the compound is reduced. Therefore, we can say that the law of definite proportion states that all pure samples of the same chemical compound contain the same elements combined in the same proportion by mass. Let me give an example. If 1.375 gram of cupric oxide is reduced on heating in a current of hydrogen, the weight of copper remaining is 1.098 grams. In another experiment, 1.179 gram of copper is dissolved in nitric acid, and the resulting copper nitrate is converted to cupric oxide. The weight of cupric oxide formed is 1.476 gram. Show that these results illustrate the law of constant proportion. In the first experiment, remember that copper oxide was initially 1.9 gram. After heating, the copper remaining was 1.5 gram. To get the oxygen present, we will have to deduct 1.5 gram from 1.9 gram. That means the oxygen present was 0.4 gram. To get the percentage of oxygen present in the copper oxide, we will divide 0.4, that's the oxygen present, by 1.9, that's the copper oxide, then multiply by 100 to get 21%. In this case, the percentage of oxygen present in the cupric oxide is 21%. In the second experiment, copper oxide is 1.4 gram. And the copper taken is 1.1 gram. Therefore, to get the oxygen present, we have to subtract the weight of copper from the weight of cupric oxide, which is 1.4 grams minus 1.1 gram. This will give 0.3 gram. And to get the percentage of oxygen present, just as the previous example, we will divide 0.3 by 1.4 and multiply it by 100, and we will get 21.4%. We can see that the percentage of oxygen is approximately, we did it within significant figure limits, is the same in both the above cases. So the law of constant composition is illustrated. We have come to the end of today's lesson. Today we learned about the laws of chemical composition. We learned the law of conservation, also known as Dalton's law, which states that matter can neither be created nor destroyed in a chemical composition. We also learned about the law of definite proportion, which states that a chemical compound is always made up of the exact same proportion of elements by mass. We will continue in our next lesson, but before we go, here is a little assignment for you to do. State Dalton's atomic theory. Send in your answers to this phone number 070-363-03182. Type your name, age, gender. If you are a boy, type male, MALE. And if you are a girl, type female, FEMALE. your class, the subject, and the state you currently live in. If you can, subscribe to our ACE Radio School YouTube channel to catch up on topics you have missed. Our channel on YouTube is ACE Radio School. Bye everyone, and be sure to tune in next week. Thank you for listening.
This is an ACE charity initiative powered by Grand Force Foundation.